Hello friends, today we are going to complete the remaining topics in inheritance theory part 3. The first topic is using final keyword with inheritance. The keyword final has three uses. First, it can be used to create the equivalent of named constant. Named constant means you are creating a variable and it is constant, like in C++ we were creating it. You can create such type of constant using final. This use was described in preceding chapter. Other two uses applied to inheritance, we will see it over here. First is using final to prevent overriding. So any method that you are telling your subclasses that this method should not be overridden in the subclasses, we will use the final keyword. While method overriding is the one of Java's most powerful features, there will be times when you will want to prevent it from occurring. To disallow method from being overridden, specify final as a modifier at the start of its declaration. Methods declared as final cannot be overridden. The following fragments illustrate what is final. Here class A is there, it is a superclass. It has one method, final void method. This is a final method. Then class B is extending A, inheriting A, and you are trying to override this same method over here, and you are trying to modify the definition of this method. But this is not valid. You cannot override. This is giving you a compile time error because final is provided over here. Because method is declared as final, it cannot be overridden in B. If you attempt to do so, compile time error will result. Methods declared as final can sometimes provide a performance enhancement. Compiler is free to inline calls to them because it knows they will not be overridden by a subclass. Because compiler will already know that this method will not be overridden by your subclass. Then a small final method is called. Often the Java compiler can copy the bytecode of the subroutine directly in line with the compiled code of the following method. So what Java compiler will do when you are using the final keyword, it will copy the bytecode for the subroutine directly in line with the compiled code. Directly in line means directly in parallel with the already compiled code of the calling method, thus eliminating the costly overhead associated with the method call. So already it is knowing that this method will not be overridden, so it can use it directly, parallelly with the already compiled code, and it will reduce the time required. Inlining is the only option with final method. When you are creating them as final, then only you can directly inline the Java compiler can directly inline the method. Normally, Java resolves call to methods dynamically at runtime. Runtime means when your method is resolved at runtime, which is called as late binding. Since final methods cannot be overridden, a call to one can be resolved at compile time. So directly when final methods are declared in superclass, compiler will know that this cannot be overridden. So call to that particular method can be resolved at compile time. This is called as early binding. So there are two definitions you have to remember. Normal Java call resolution to method is done at runtime. This is called as late binding. And when you are declaring any method as final, this method cannot be overridden. The Java compiler will know and it can resolve that method at compile time itself. This is called as early binding. Compilation is done before running. The compile time is early binding. Compile time binding is early binding, and runtime binding is late binding. Using final to prevent inheritance. Sometimes you will want to prevent a class from being inherited. In the previous usage of final, what we saw, the final keyword will prevent the method from overriding. But sometimes you will want to prevent a class from being inherited. To do this, precede the class declaration with final. So any class that is declared as final cannot be inherited by any class. So any subclass, any class cannot inherit this class, or any class cannot get the properties of this class. Declaring a class final implicitly declares all of its methods as final too. Implicitly, methods will also be final. As you might expect, it is illegal to declare a class as both abstract and final, since the abstract class is incomplete by itself, and it relies upon subclasses to provide complete implementation. You cannot write one class both abstract and final. When you are declaring a class as abstract, its definition must be written by a subclass, as we have seen. And when declaring a class as final, it cannot be overridden. Since abstract class must be inherited, must be implemented, and final class cannot be inherited, you cannot combine them both. Here is the example of final class. Final class A, class B extends A. This cannot happen. Illegal for B inherits A, since A is declared as final. Object class. There is one special class object defined by Java. All other classes are subclasses of object. That is, object is a superclass of all other classes. If one special class object, superclass of all other classes. Reference variable of type object can refer to an object of any other class because it is the parent class of all other classes. The very important line you have to remember, which is the parent class of all other classes, it is a object class. And when you are creating a reference variable of type object, it can refer to any object of any other class. Also, since the arrays are implemented as classes, a variable of type object can also refer to any array. Array are implemented as classes. It's a very important line. A variable of type object can also refer to an array, because array is also a class. Object defines the following methods, which means they are available in every object. So following object methods we are going to see will be available for every object. Every object can use those methods. Clone creates a new object that is same as the object B. Clone is copy of the object. It returns object. Boolean equals determines whether one object is equal to another, returns true or false. Void finalize. This is finalize method called before unused object is recycled. Class get class. Finalize you have already seen. Class get class. Get class returns the class. Obtains the class of object at runtime. So if you are confused about from which class this object is, you can call the get class method on that object. It will return the class of an object at runtime. Integer hash code. It will return an integer. Returns the hash code associated with invoking object. Notify. Resumes execution of thread waiting on the invoking object. When we will be seeing the threading, multi-threading, we will be understanding this method notify. Also notify all. Resumes execution of all threads waiting on invoking object. String to string returns a string that describes the object. So object description in string format will be written in from this method. Then void wait long millisecond, void wait long millisecond, integer nanosecond. Waits on another thread of execution. The methods get class, notify all, and wait are declared as final. So this cannot be overridden. You may override the other method. These methods are described later in the multi-threading chapter. However, equals and toString are easy methods. You can understand them here. Equals method compares the contents of two objects and it returns true if objects are equivalent and false otherwise. The precise definition of equality can vary depending upon the type of objects being compared. And the toString method returns the string that contains the description of object on which it is called. Also, this method is automatically called when you are calling the println system.out.println. always it is automatically called toString method. Many classes override this method, toString method. Doing so allows them to tailor the description specifically for the types of object that they create. So many classes can override or generally override this method, toString method, and doing so it can define the description, specific description for the type of object that they are creating. So this way we have completed all parts from inheritance. In the next session, we are going to start the practical part of inheritance. To meet you in the next session. Thank you so much.